In this video, I will telling you the solution of problem C of Codeforces round 810 division 2. So in this problem, we have been given an n cross m grid, and we have k pigments of different colors, and each pigment has a limited quantity. And a picture is considered beautiful if each cell has at least three toroidal neighbors with the same color as itself. So means a picture will only be beautiful if it has at least three toroidal neighbors, and the color of those three neighbors should be same color as itself. So we have so these are the n, m, and k are given in this question, and the value of the amount of each of these pigments present is also given. So in this problem, we will have to make two observations, and I will try to explain to you why those two observations are correct. In the first observation, the first observation is that either all the elements of a row are colored with the same color, or either all the elements of the column are colored with same color. So suppose we take this cell and it has four toroidal neighbors, this, and we try to make the color of these three toroidal neighbors as same. So let's assume as C1 C1. Then we consider this cell, and it will have its toroidal neighbor as this, and we will try to make these color of these two as equal. So it will come as C1 only. This color will also become C1. So suppose now we consider this cell, and the two toroidal neighbors are this and this. We will make it C2 for now, and then we will try to consider some different cell like this cell, and we will see that these two will have to be same. C1, one of the toroidal neighbors is C1 and other is C2, so this will have to be same. So this will also be colored as C1. Similarly, if we consider this cell, then the two of its toroidal neighbors is this and this, so this will have to be C1. So we have proved that means if we are considering the toroidal two of the toroidal neighbors in the same column, then all the elements of the column will have to be of the same color. I'm repeating it once again. If all the elements, means if we are considering for an element two of its toroidal neighbors of the same color in the same column, then all of the elements of the column will have to be of the same color. And since you can say there is symmetry between rows and column in this problem, so we can also say that similarly means either this will have to be true, either all the elements of column will have to be of the same color, or either all the elements of the row will have to be of the same color. Means either this one will all be same, means for similarly for this all will be of the same color, or either this whole column will be of the same color, and so on. And the second observation which I have to make is suppose we are considering the case where all the elements of the means all the color of all the elements of the column is same, then at least two means color of two consecutive columns will be same. Why I'm saying so see, we can see here that for this cell there we have two toroidal neighbors. So supposedly we consider one of its other toroidal neighbor as this, so the color in this also becomes C1. And then if we try to proceed, means by considering this cell and considering its toroidal number, this toroidal neighbors as this and this, then it will also become C1, and so on. So the other means the second observation is, if we are considering color of all the columns, all the elements of column to be same, then at least two consecutive columns will have the same color. Or if we are considering the color of all the elements of the row to be same, then then at least two consecutive rows have to be of the same color. After I'm done with this observation, I will try to show you how we will color it, means how we will try to color the following 9, 12, 8. This is the first test case, I guess. 12 line 8. Yeah, order does not matter, but 12 line 8. So what we can do is we have 4 rows here, and 4 rows and 6 columns. 3, 4, 5, 6, and 4 rows. So what we can do here is we can we can try to make all the elements of the column to be same. So we can do is we can color it with first color, first color, first color, and then what happens is that if the at least 2 consecutive columns have to be of the same color. So we will try to color it with one, and we'll see that the pigment one is in sufficient quantity till now. And then what we can do is we can try to color the next column with the next color, 2, 2, 2, 2, and then since at least 2 consecutive columns will have to be of the same color, then we will have to color this in this way, and then this, so on. So this is the strategy which we are following. Means one another possible strategy means you could possibly imagine is if in this case means if we consider a different test case where we are having means 6 total number of rows and 4 columns, then means you can I will try to show it to you. 1, 2, 3, 4, 5, 6, and here it is 4. So what we can do is we can try to make all the elements of a row same, and at least 2 consecutive rows will have to be same. So we could color it in this way. So this picture becomes a beautiful picture. So I'll now try to show you the code and explain my solution. So what I'm doing is I am in the first part of the code, what I'm trying to do is I'm trying to make all the elements of a column as same. All the elements of a column as same. So I'm trying to find out how many different columns can I fill with a particular pigment. And if the number of columns which I can fill is greater than 1, means at least 2 consecutive columns I can fill with the same pigment, then what I'm doing is I am pushing this value, the number of columns, the number of consecutive columns which I can color with this pigment into an array. And then if the size of this array is greater than 0, then I am trying to check how many total number of columns I can color with the given amount of pigment, such that the picture we are able to make is a beautiful picture. So if the number of columns comes out to be even, so I am simply adding a condition that if it is greater than the number of columns present, if the number of columns that we can color using the given pigment is greater than the number of columns present, then we are printing the answer yes. Or if it is odd, then then 2 cases I'm considering. If it is exactly equal to m, then I'm printing yes. Or if it is greater than m, then I'm checking that at least one pigment is there which is able to color means greater than 2 consecutive columns. Why in the odd case I have to write an additional condition, I will try to show it to you. Suppose we have 5 columns, and we have 5 columns. 1, 2, 3, 4, 5. We have 5 columns, and we have suppose 3 pigments, and each can color 2 consecutive columns. So what will happen? We'll color the first 2 consecutive columns with the first color, the next 2 consecutive columns with the second color. But then what will happen? We will have the third pigment, and we can use the third pigment to color 2 consecutive columns. But we are having only 1 consecutive column. We are having only 1 column left. So we will need to have like we will need to have 2 pigments, which one can color 2 and the other can color 3. So what I'm saying is, so this condition is there that at least if if it is coming out to be exactly equal to the means if m is odd, and if it is exactly coming out to be odd, then what actually is happening is that in the stored array at least one of the elements is odd, or otherwise this will not be possible. Like if m is suppose 7, then it has to be something like this: 2 plus 3 or 4 plus 3, or it will not be able to come equal to that. But if it is greater than m, if AD is greater than m, then there may be a case where 4 2s are present, and in this case we will not be able to consider color it. So I'm putting an additional condition that at least one of the elements should be greater than 2. So like 2 2 3. So this is the condition which I'm putting here: AD greater than, or AD greater than m, or a max number of consecutive columns that we can color is at least greater than 2. Then in that case I'm printing yes. Similarly, since there is symmetry between rows and column, so for in this case I'm trying to color the all the elements of a row similar, and storing the values for all those pigments which can color all, two consecutive rows with the same color, and trying to do the same thing if the number of rows is, or if the number of rows is odd, or if the amount of pigment which is available with us is greater than equal to n, then I'm simply printing yes. Or if it is odd, then I'm doing the thing which I explained above. And if we means if we try to follow both the cases, and in none of the cases if we are able to create a beautiful picture, then I am printing no. So this was the solution. Hope you liked it, and do check out the code in the description, and thank you.